Hello everybody, I'm Emily Machina, and today we're watching the video What is ChatGPT Part 1. This is part of a couple of workshops I'm holding in person, but I'm also releasing videos so the people that can't come in person can also get the experience. So, this video will be broken into two parts. In Part 1, we're going to talk about what we mean when we say AI. How do AIs generate text? Why do generative text AIs hallucinate? And I'm going to go over like a brief overview, a very high level of what ChatGPT actually is. In part 2, we're talking about the basic limitations of generative AI, the environmental impact of large AIs, the huge amount of human effort required for AI. It's a lot, folks. And the impact AI has on humans today. So first, and I'm only going to do this in the very first video in this series, not every time, I'm going to go over who I am. I'm an Emily Machina. I'm currently a PhD student in computer science. My research is explainable AI in natural language processing. That's a bunch of academic jargon, so that means I'm looking at how an AI goes from an input to an output, or how an AI structures its outputs and the types of patterns that can be found in there, and maybe how an AI changes if you modify some things slightly, things like that. And natural language processing means I focus on AIs that take text as input. Since the specific type of AIs we're talking about today are machine learning, I should note that they're all pretty similar no matter what input they're taking in. So while I may not be able to tell you exactly what's going on with the state of the art in, say, picture AIs or video AIs, I could read the papers and understand what they're doing because sort of the foundation is pretty similar, if that makes sense. So at the time of recording this video, I'm currently doing my research at the University of Western Ontario with my supervisor, Dr. Robert Mercer. I also work with the local student union where I'm the speaker. If you have a system of government where there's a speaker that does a job, maybe runs the meetings, that's what I do for this organization. I've worn a lot of hats in my day, but that's what I'm doing right now. I also do some consulting work for the Vector Institute of Technology, where I help them with their AI boot camps, where they try to teach people AI skills. And I work for a company called NomiQ. I'm their AI person. If you want to see what they're working on today, feel free to Google them, because I don't know what they'll be working on when you see this video. And I have to say, this video and these slides, the creation of them was partially funded by the Digital Research Alliance of Canada as part of their Digital Research Infrastructure, Equity, Diversity, Inclusion, and Accessibility Champions pilot program. I was one of the 80 projects that got approved, and sort of the idea is if you sort of understand how these AIs work and know that they're not magic or scary, then maybe you'll use them more. And then the next workshop after this will be sort of teaching you how to use them. So what do we mean when we say AI? Almost all the AIs you see talked about in the news or actually in research these days are a thing called machine learning. And there's some debate about whether machine learning qualifies as AI under the average person's definition of AI. Because they're not like the AIs you see on TV. They're not like your Star Trek computers or your Jarvises. They're a lot more statistical modeling. But the reason why they're called AI is because they fall into the computer science research field of AI. So in computer science, they're AI. To you and me, like having a conversation at a coffee place, are they AI? Maybe not. So let's talk about what a large language model is. You've probably heard a lot about large language models. And you might have heard that ChatGPT is a large language model. It's not. ChatGPT is not a large language model. ChatGPT is an interconnected system of tools, of search algorithms, of different AIs, most of them using machine learning. One of them is a large language model for sure, but it is itself not a large language model. But you might have heard it is, because a lot of corporations and people that stand to make a lot of money have sort of an interest in convincing you that it's just a large language model. It sort of helps them justify training the large language model on copyrighted data. It sort of justifies the poor working conditions that the people that help train the large language model might be living under. Maybe makes you think if it's just one thing that's passing the Turing test and doing all this stuff, that maybe we're closer to AGI. Various reasons. I can't really read their minds, so I don't know. But let's talk about how a large language model relates to ChatGPT. You can think of it as a car engine. A car engine, or like an engine in general, does one thing very well. It moves sort of like a piston up and down and up and down and up and down, which is great. It does that very, very well. But moving a piston up and down does not get you from point A to point B. It doesn't turn that movement into electricity. It doesn't make a car radio work, right? It's just part of a system that makes the car go. And if you've ever seen on social media, hey, these people gave ChatGPT some text and it did something weird, they don't fix that usually by training the large language model. The research shows that that doesn't even really work. What they do is they have another AI, possibly also machine learning, probably another text AI, you can think of it as the radio, and they just change the radio so that attack doesn't work anymore. So they have like a spam filter, an attack filter, and like that's what's stopping the attack from happening the next day. They didn't just train the large language model to stop it. A language model does one thing really well. It models a language that it was trained on, and we'll talk about what that means later. And you can use that language model, given a set of input, called the prompt, to generate the next token, and the next token, and the next token, sort of like a car engine, moving a piston up and down. And this is not a new idea. We've been modeling languages for a long time, and we've been using those language models to generate text for a long time. One of the things these new AIs do really well is they generate coherent text. So if they're trained on English and you're a native English speaker, their outputs look like English. There's not like any weird orderings of the words that might confuse you, or maybe it starts repeating itself a bunch. That doesn't happen anymore. And that was really a good thing that came out of these new LLMs, in my opinion. But they really are just generating one token at a time. Let's go back to the original question. What is an LLM? LLMs are made of two things. The first is parameters. And you've probably heard, if you read the news, this AI has 5 billion parameters. This AI has 1 trillion parameters. The new best, because it's biggest AI, now has 170 billion parameters. What's a parameter? In the context of machine learning? Parameter is a number. 1, 2, the negative square root of 5, 3.5. It's a number. This may not be true if you go to other types of research, like other types of math research or other types of computer science research, but for machine learning, they're numbers. So when we say an AI has 5 billion numbers, if you download that AI, you have to download those 5 billion numbers. The second thing an AI has is instructions on how to use the numbers, because the numbers don't really do much on its own. And those are the two major components of AI at an abstract level. At a lower level, there's also the hardware. The hardware is necessary for the AI to run, but the sort of AI exists without the hardware, in my opinion. And we should note that when you train an AI, you're really just changing the numbers. The instructions often don't change at all when you're training an AI. It's just the numbers go up or down or get bigger or smaller to make the AI's predictions better. So yeah, those are the two main components of an AI. To walk you through this, I'm going to introduce the concept of Simple GPT. It's a fun little AI that has 3 parameters, and it has instructions on how to use those parameters. So if we got an input, We could turn that input into a number. I will get into how that happens later. We can do our instructions on that number, and then we'll get an output. But how do we turn the output back into a word, right? Because we turned text into number, we did math on number. How do we go number to word again, right? Because that's the end goal, was to generate a next word. So we'll have to introduce something called a vocabulary. All of these new text-based AIs have what's called a vocabulary, and that is just the set of words that it knows. Here I've associated each word, its number in the list. So the first word gets the number 1. So if we give the AI an input and all of the words in the input are in its vocabulary, the AI is happy and it can turn that input into a number. However, if we gave the AI an input and one of the words wasn't in its vocabulary, it doesn't like that, and it doesn't know what to do with your arcane sigils or wizard speech. Talking about modern machine learning AIs, the second case is never a problem. Their vocabulary isn't strictly just words, and they can sort of represent any word but based on their vocabulary. But we'll talk about that in part 2, because it does have its limitations. So now we have the vocabulary. So now we can predict a token, because we have the output 4.38, and the closest word to 4.38 is dog. So we just choose the closest word to the output. And so we turned I saw a into I saw a dog. We did it. We generated a token. We went from an input to the next token. And we could do it again. Just do the same thing with I saw a dog. And then do the same thing with whatever the next word after that is. We did it. Yay. So I actually didn't tell you how the first step works, right? So, okay, let's go into that now. So when I first introduced the vocabulary all of 1 minute ago, we saw that each word was associated with its position in the list. That doesn't work so well. So I am proud to announce you have an exclusive look into the new cutting edge example AIs, Simple GPT Plus. Simple GPT Plus has 3 times as many parameters as the previous AI. And we've also updated the algorithm it uses to generate tokens. And what did we do with those new parameters? Well, we associated one with each word in the vocabulary. Okay, that was supposed to be a joke. I don't know if it ever lands because people don't talk it during workshops. But I'm sort of making fun of AI version numbers. It's not like when Windows 11 came out and obsoleted Windows 10, or Windows 10 came out and it was a lot different than Windows 7. Not much changes between AI versions. Sometimes it does, but most of the time it's just marketing. Oh, we added some more parameters, we trained on a bit different data, we changed something small about the instructions. It's not really, they're not real. They're not real is the thing. Okay. We have Simple GPT Plus, and now it has one parameter for each word in the vocabulary, which means because these parameters can change, it can learn something about the words. Because now it has a way to sort of adjust a parameter to sort of adjust to the meaning of a word. That's really good, right? Because before they were fixed, and now we can sort of learn things about them. And now we also have a really good way to turn input words into a number. We can just sum the numbers associated with each input word in the vocabulary. Great, right? So I saw becomes 0.9 because that's the sum of all of the numbers associated with the words in the sentence. 0.9 gets turned into 2.28 when we follow the instructions that were there before. And then we do the same thing. 2.28 goes to the word dog. So now we have I saw a dog again. We did it. We went from text to the next token. We know how all of the steps work. And yeah, it's a simplified version, but this is how it works. Like, there's no magic. It's a little bit linear algebra, though. I'm going to go into training now, but I'm not going to be able to talk about it in a lot of detail because we've simplified things so much. But these steps here, instead of like multiplication, just think linear algebra like a matrix. A matrix is just a bunch of multiplication and addition all at once. So it's not anything different than what you've seen here. It just happens all at the same time. And I won't be able to go into like specific details about the training because you do need a first year linear algebra understanding to understand sort of how the training works in detail. But I can still talk about it at a high level and hopefully you will learn something. It'll be great. Don't worry, but it's first year linear algebra, not fourth year mathematics, not graduate school mathematics, first year linear algebra. So how do we train this AI? Because the AI we had before sort of seemed to know what it was doing. How do we get to that point? So at a very high level, machine learning is taking some input and then giving it to sort of an agent of chaos. When these AIs are first sort of created, their parameters are random. The instructions are not random, the instructions are fixed, mostly. But the parameters are random. You can think of each parameter gets a value between -1 and 1. And so they look nothing like their input. But you sort of give it the input, you tell it if it's right or wrong, and then it sort of starts to develop some structure in the chaos. And then when you're done training, it sort of models the statistics found in the input. It may not look exactly the same, but there's some of the patterns are pretty similar. So how do we go from chaos to order? We have things called training examples, where there's an input and a desired output. So if we think about the previous step we did, where we were just generating tokens, when we generate the word dog here, it is neither right or wrong. We have asked the AI to generate a token, and it does. There is no notion of correctness in this algorithm. We might read it as a human and go, I hate it, that doesn't make any sense. Why did you generate the word I saw a I, if say it did that? But the AI is doing exactly what it has been asked to. We gave it an input and we asked it to follow its instructions to generate another token. And this is sort of one of the reasons why hallucinations happen, is because there's no right or wrong answer when the AI is generating its token. It is only us that give it a right or wrong answer at the end. But that's different during training, because during training, you have a desired output. So if we look at this previous step, if it was actually the training example, I saw a and dog, then yes, dog would be correct. And if it was anything but dog, it would be wrong. Even if it makes sense to us, like cat, it would still be wrong because that's what the desired output is, the label. They call it a label. Similarly, we could have other training examples, like the word word should come after the word Microsoft. So what happens at a very high level during training? So say we gave the example, I saw a with the label dog. Simple GPT Plus gets it, predicts dog. This is a correct prediction. The training instructions at a very high level are update the parameters so next time the same input is closer to dog's parameters. Because remember, the parameter for dog can change, but what we want is that this time the difference between dog and the prediction is 0.02. Next time we want it to be 0.015. And then the next time 0.013. And then the next time 0.01. Right? The difference is what matters here. So we want that difference to shrink. And it's not much different if the AI got the prediction wrong. Our end goal is for the output to be very close to the parameter for the correct label. So that's what we ask the AI to do. Again, you don't really get an idea of what this looks like unless you know a little bit of linear algebra. If you do know linear algebra, you could probably look at another course that will teach you this, and you'll be able to understand what's happening because you'll understand matrices. So at this point, we can talk about how a lot of AIs are trained in machine learning. We could train a spam detector GPT. The training examples would be emails, and the desired outputs would be whether the email is spam or not spam or an ad or malicious. This AI would have a vocabulary because it does need to turn the email into numbers to do math on it, but we can't really, or we could, but we shouldn't, turn that number into a next token, right? That doesn't really tell us if it's spam or not. So what they do is they add what's called a classifier, or I've called it here a label vocabulary to link it to what we talked about before. And essentially each label, spam, not spam, has a parameter associated with it. So you turn the email into numbers, you do math on the numbers, and then the result of that math is compared against the label vocabulary to determine if it's spam or not spam. This is the same thing that happens with, say, image classification. You turn the picture into numbers, you do math on it, and then you have a label vocabulary that tries to tell you which animal is in the picture and things like this. This is not the only way to train an AI. However, it's like one of the most common ways. It's called supervised fine-tuning if you're more interested in the technical details. So let's go back to simple GPT+. In order to train the AI, we need examples. The examples come from what's called a training corpus. We really don't want to do this by hand, but we're in luck because humans do a lot of writing. And the corpus is made up of a bunch of documents. So books, Wikipedia articles, YouTube captions, social media posts. Some of the things I have mentioned there are copyright, but they still get trained on. So we have these documents. So the training corpus is some subset of documents of written language that exist on the planet when it was trained. We take those documents and we extract the sentences from them. And then if we have a sentence, you can sort of cover up part of the sentence and then move it one word over and you have an example. And what I mean by that is you sort of break the sentence into each of its examples. You can do this one for each word in the sentence. And you do this for every sentence that is in your training corpus. And that's how you get these training examples. So you find a corpus, which is documents. You turn the documents into sentences. You turn the sentences into examples. And you train the AI on the examples, and you're done. The AI models the language of the documents. It's training data. And we'll talk about what that is in 1 second. I did want to address one thing because maybe you're paying very close attention and you notice I've sort of lied to you. So we did talk about how an AI can't do anything if its vocabulary doesn't contain the words in the training data. So just pretend we're talking about simple GPT++. And all of the words are in its vocabulary. We will get into what the vocabulary actually is in part 2. What does it mean to be a language model? So I'll tell you right now, if this was the training data for our AI, and we trained the AI and we started generating sentences, these 3 sentences, if we counted how many times they got generated, would appear with equal frequency. Because they appear with equal frequency in the training data. It's modeling the statistics of the training data. In fact, something stronger is happening. Because the AI only knows words by its context, which are the words to the left of the word dog, cat, and person have the same parameter value. And that's because they have the same context in the same frequency. So to the AI, if the AI is trained on a very good algorithm, they are exactly the same. There's no difference between them as far as the AI is concerned. And here's where I would ask a question to the class, but you can think about it yourself. What happens if we add I saw a dog one more time to the training data? What do you think is going to happen here? I would pause for a second, but you can actually just pause the video or fast forward it, so we're just going to keep going. Actually, it doesn't do what you'd think. I saw a dog would be generated 100% of the time. And you'll note that doesn't model the statistics of the language. So why does this happen? Well, if you remember the algorithm we use to predict a next token, the parameters are fixed, it goes through its algorithm, and it chooses the closest word every time. And that will always be dog, because training is done, so the parameters are fixed. So this is where we sort of add the first extra piece onto the engine. We can add an alternator. So what we do is instead of just choosing the closest word, we sample from like the top 3 words or the top 10 words. If you've ever used a chatbot interface that has a temperature parameter, that's sort of what's controlling this. If the temperature is 0, you choose the closest word every time. If the temperature is, say, 0.5, you sample from the top 3. If it's 1.0, you sample from the top 10. And you don't sample randomly, you sample based on the distance between the predicted number and the parameter for each of those labels. So if we do this, we again get the language model back. I saw a dog would be generated twice as often as I saw a cat and I saw a person. I will note this randomness, choosing randomly from the top 10, is called creativity in marketing. If a corporation tells you their AIs are creative, it means random stuff happens and it's different. And like, I don't know, you've probably used AIs, maybe. Okay, maybe it's creative, but it's the process of creativity is just randomness. It's not like, there's no intent behind this creative process. It is a random algorithm. Just if you ever thought that maybe the AIs were planning their creativity. So we've sort of gone over, and I'll summarize this now, 2 reasons why AIs hallucinate. The one is when they're generating a next token, there's no notion of right or wrong. It's just doing exactly what we asked it to do, and that is generate another token. The next thing is that nowhere in this process, right, I just showed you how the AI generates text. Does the AI go, hey, is the thing I'm generating factual? There's no check for that. An LLM doesn't do, hey, is this a real thing I'm generating? Right? Because that's its instructions don't say, hey, check to see if this is a real thing that exists. Because if you had a good way to check that, you probably could use it to generate better text than the LLM. But there's some other reasons too, but like those are the 2 main reasons. So the AI is doing exactly what we tell it to do. It's only when we read the text later that it has mistakes in it, factual mistakes, that we as humans think it did something wrong, but it's doing exactly what we told it to do. Don't be mean to the AI. You told it to do a thing and it did the thing and then you didn't like it. That's sort of an us problem as humans. And, you know, I've tried to simplify things here, but even with this simplified view, we can sort of see that interesting things are happening. Because if the AI is modeling the statistics of its training data, then if we looked at the top 10 closest labels, or in the vocabulary, to I tasted the most delicious, they must all be close to each other, right? And those would be things that are described as delicious in the English language. So there's a delicious part of the vocabulary, and there's a disgusting part of the vocabulary, and there's a tall part of the vocabulary, and a short. So like, even with the simplified view, we can see that interesting things are happening, because if it's modeling the statistics of the language, it needs to sort of model these categories that we as humans have, because that's how we use the language that the AI is modeling. Like, interesting things happen. It's not magic, it's math. It's math and statistical modeling. It's okay. This might be why you're here. What is ChatGPT? I said I would get into it. So I have to do a disclaimer. The actual processes behind ChatGPT are corporate secrets. I can't know exactly what it does. What I'm showing you here are the best estimations of researchers who are better than me at this sort of thing. And they sort of say they get similar results to what ChatGPT is doing. Also, things change very fast, even in the research point of view. So if you're watching this video 2 years from now, I might be out of date. Sorry. I don't know what to say about that. Sorry. Okay, so let's talk about the components of the ChatGPT car. So I'll do this by just walking you through sort of what happens. We get an input, and that gets given to a tiny LLM. Why a tiny LLM? Because it's fast, and we want it to generate a lot of sentences using that sort of random algorithm. So the tiny LLM looks at the input, it generates a bunch of sentences, 1 token at a time, and then we have, say, 100 sentences. Those 100 sentences are sent to the big LLM, which scores the sentences based on its language model. How does it score the sentences? It turns each of the sentences into training data, pretends that it's training on them, and then if it would have done well on the training, so it predicted, the correct token most of the time, it gets a high score. That sentence gets a high score, and if it wouldn't have predicted that token for most of the sentences, it gets a low score. Sorry, I keep saying token instead of word. You'll find out why in a second. So now we have a bunch of sentences that have been generated by a tiny LLM and scored by a big LLM, and those go to a search algorithm. I'm not going to like go into the search algorithm. Choose your favorite one if you know computer science search algorithms. Beam search, A-star search, these are not magic either. They are like very concrete algorithms for choosing the next path to take given your current state. And so this search algorithm chooses the next sentence to expand, which means that we add the current sentence that was chosen to the current input, and that gives us a new input, and that goes back to TinyLLM. So this is sort of the basic loop that it uses to generate your output. Now, a newish thing that came out is sort of called a verifier or self-consistency. And you can think of this as a new component called Are Things Going Well GPT. And I call it that because it predicts basically yes or no. And if the answer is yes, the algorithm continues, so we go through this loop again. However, if the answer is no, we back up a few steps because the search algorithm says, whoa, let's back up a few steps. I want to try another sentence to expand. And that's sort of it. How do we know that Are Things Going Well? GPT knows what it's doing. Well, it's trained on a corpus of data full of examples created by a bunch of humans. Like a bunch of humans looked at a bunch of outputs for AIs and rated them good or bad. And those were used to train Are Things Going Well GPT. So like a bunch of humans actually had to help you do this one. It's great. Humans are great. And this is the end of part 1. I'm going to actually make these 2 different videos. So please look for part 2. It'll probably be, I'm assuming this is going to be on YouTube. It'll be in the comments. And if you found this on GitHub, it'll probably be in the folder that you saw this video. Or it'll be somewhere near there. There should be a README. You should look at the README. It'll tell you. So thank you for watching. And hopefully you stick around for part 2. We're going to get into the vocabulary. And we're going to go into like some more of the social aspects of AI and sort of their impact on us right now as humans. So, okay. Bye.